In this video, I'm going to try to summarize the main idea in solving rational equations. So I've written up an example problem here. Our strategy for solving equations like this is going to be similar to the strategy that we used for solving linear equations that involved fractions. The idea is that we first want to eliminate all of the fractions, and then after that we'll be able to solve the remaining equation. And remember that whenever we're trying to solve an equation, what that means is that we're looking for all of the x values that you could plug in that would make this equation true. So that's what we're looking for here. And just like with fractions, it's a good idea to start by trying to kill all of these denominators. So let me just list the denominators. The denominators are x minus 2, and then x. And it's a good idea, just like with ordinary numbers, to factor each of these denominators because we're about to find the least common denominator, or the least common multiple of these denominators. So I'll write the first two denominators as they are, but the second denominator, this last denominator, I notice I can factor as an x times x minus 2. So these are the three denominators that appear in this problem. And just like with our approach with linear equations, to kill all of the fractions, I just want to multiply both sides of the original equation by the least common denominator. So let's find the least common denominator. To find the least common denominator, you just list all of the factors that appear in all of your denominators. So notice that the factor x appears and the factor x minus 2 appears. And for the least common denominator, you need to include each factor that shows up the greatest number of times that it shows up in any single term. So the most number of times that x appears in any single term is once. So this would be x to the first power. And the greatest number of times that an x minus 2 appears in any single factor is also once. So this will just be x times x minus 2. That's the least common denominator here. And now we're going to take the original equation and we're going to multiply on both sides, by this least common denominator. So I'll take x times x minus 2 and multiply on the left side of the original equation. And I'll also take x times x minus 2 and I'll multiply on the right side of the original equation. And if you'd like, you can also write the original right side denominator in its factored form. So it doesn't really matter how you decide to write this on the right side. But all that I've done here is I've multiplied the left side and the right side by x times x minus 2 because I want to kill all of the fractions before I proceed. So on the right side, things are especially simple because here we're going to get a lot of cancellation. So notice that I have an x in the numerator and also an x in the denominator. So those are going to cancel, so I can cancel this with this. And similarly, I have an x minus 2 in the numerator and an x minus 2 in the denominator, so those are going to cancel. And that means that this right side is just going to be 2x. Now on the left side, what I have to do is distribute this outside factor to each of these terms on the inside of the parentheses. So I'll go ahead and distribute there. So if I distribute x times x minus 2 into the parenthetical term, what I'll get is x times x minus 2 divided by x minus 2. That's this first product. And then for the second product, I'm going to do the same thing. I'm multiplying 1 over x by x times x minus 2, so that x times x minus 2 goes up into the numerator, and this will be over x. And we've already seen that our right side simplifies to just be 2x. And now again, I can look for cancellation. So in this first term, I have an x minus 2 factor in the numerator and the denominator. In the second term, I have an x factor in the numerator and the denominator. So those are going to cancel. And then after cancellation, what I'll get is an x minus an x minus 2 equals 2x. So that's what we get after just cleaning up the above line. Now notice that this minus sign that's sitting between these two terms does apply to the entire right side term. So we will need to distribute this minus sign. and that would give us an x minus an x plus a 2 is equal to 2x. Okay, so once you've killed all of the denominators, what you'll be left with is an equation that will look something like this. It won't necessarily be a linear equation like this one. It can be any polynomial equation. And polynomial equations are the ones that we talked about last week. So you may need to use the techniques that we talked about last week to finish these problems at this stage. But thankfully for this particular problem, we get this nice linear equation. I can combine these like terms on the right side to just get, on the left side to just get 0. So this reduces to the equation 2 is equal to 2x, and then dividing both sides by 2 will get you the solution x equals 1. In these problems, you'll come up with a candidate solution like this, x equals 1, and then the only thing that you need to check in these problems is that you are allowed to plug in 1 in the original equation. So let's go back up to the original equation, and let's look at these denominators. I can plug in x equals 1 here or here or here without causing any problems. In other words, plugging in 1 is not going to cause any of the denominators to be 0. So the input 1 would not be problematic here. And that's all that you have to check. You can plug in 1 and check that the original equation holds, but the only obstruction to the original equation holding is just to have a 0 in one of the denominators. So since 1 doesn't cause a 0 in any of the denominators in the original equation, we know that x equals 1 is our solution. And these equations can have more than one solution. So in the notes, I'll just ask you to read over the notes before you start looking at the example videos, and then you'll see several examples where there are more than one solution.